Hey guys, welcome to question MM168 of the Maths Methods Fortify study guide. Now, this question is a little bit of a doozy, so if you had trouble with it, don't worry, it is a very, very difficult question. It's probably one of the more difficult differentiation multi-choice questions. So, we've got this function y equals e to the power of x, and a tangent passes through that function at the point p, e to the power of p, where p is our x value and e to the p is our y value. And we know that that tangent crosses the x-axis at the point a, 0, where a is greater than 0, okay? So maybe even let's just draw a quick diagram for this. So y equals e to the power of x looks something like this. Actually, I'll make it a bit steeper there. So something like this. And we know that there's a tangent at the point p, e to the power of p, right? So this is p, e to the p, passes through like this, right? It passes through the x-axis at a0, and we know that a is on this side because the question tells us that a is greater than 0. Okay, so it's on the positive side of the axis. Awesome. Now, what we want to do is determine which of the following statements are false. Now, I know that it's hard to figure out what to do here. Because there's no real algebraic way of moving forward unless you kind of seen a question like this before. So just bear with me. These kind of questions, you're just going to have to keep practicing to kind of get the hang of them. So we know that the tangent passes through p, e to the power of p, and a tangent is just a straight line, right? So actually, you know what? Let's do it a different way. So let's say that the gradient of this tangent is equal to the derivative of the function, which is y equals e to the x, at that point, okay? So if y equals e to the power of x, we know that dy dx, or the gradient of this tangent, is actually equal to e to the power of x. That's just our rule, right? We know that the tangent is at the x value p, which means that our gradient is e to the power of p, okay? So keeping in mind again, guys, that gradient is equal to rise over run. We've got 2 points here. We know that the gradient of this we know that the gradient of this tangent is e to the power of p, which is the line between these 2 points here, which means that our gradient, m, is equal to y2 take y1 over x2 take x1. Our gradient is e to the power of p, which is equal to y2, so e to the power of p, minus 0 over p minus a. Awesome. So now we want to rearrange for a, because a is the sort of thing that we're trying to find. I know it's difficult to see that a is what we want, but that's going to tell us what we need to know. So from here we bring this up to here, we multiply that out, so we get p e to the power of p minus a e to the power of p, and that's equal to e to the p. Awesome. From here, we want to get a by itself, so we end up with e to the power of p, bring that over and bring this over here, p e to the power of p minus e to the power of p. Because we've got e to the power of p on each one of these, we're actually just going to divide everything by e to the power of p so that we can get rid of it. What happens there is that cancels, and that cancels to a 1, which means we get a equals p minus 1. Awesome. So from here, we know that a is greater than 0 because the question tells us. If a is equal to p take 1, that means that p take 1 is greater than 0, which means that p is greater than 1. Just bringing this over here. This is the crazy part. If p is greater than 1, that means that e, 0 to p, so p is between 0 and 1, this must be false, right? Because if p is greater than 1, it can't be between 0 and 1, which means that e is our answer. I know this is crazy. I know this is intense. If you haven't seen a question like this before, it's unlikely that you would have got it. If you did, awesome job, because this is a really difficult question. Hit me up with any questions you have. I'm not too sure what kind of questions you're going to have, so I didn't address specific questions now. But if you're having trouble figuring out what I've done here, just let me know and I can answer any questions that you've got. But otherwise, guys, try not to freak out too much. This is a really tough question, and it's designed to stretch out the bell curve, and it's designed to differentiate between the really high range students. So as always, guys, thanks so much for watching, and let me know if you have any questions.